Good morning, everyone. Today we're going to expose Chaos Toolkit against our system and see how Chaos Toolkit can help us find or discover some weaknesses through chaos engineering. Our system is made of a single web app that basically looks up its data, its records from a database, a relational database. All of this runs in a Kubernetes cluster. The database has two instances, and the application is connected to one at any point in time. And we'd like to know whether or not there is actually a weakness between those two services, the application side and the database side. What happens if the link goes away or if the database goes down? And that's the idea of that chaos experiment that we're going to run. Now, to help us out here, we're going to rely on Weave Cloud to actually provide us first a view of our topology of our system and see how it looks, if things are connected and stuff like that. But also automate for us the automated release of the response that we may actually provide if the weakness is found and fixed. On top of that, we're going to rely on Slack to help us as a team see what's going on while we run that experiment. All right. So let's get going. So application is made, let's go back to the code because that's really where it happens, right? Our database lookup is done into that call here. So what we say is we make a select statement here, right? We connect. But what happens if the connection is gone? Well, what we do know is in that specific case, it's going to probably trigger an exception and impact the user in the sense where the availability of a web app is not going to sustain. Basically, it's going to be reliable. So that's the whole point of that chaos experiment. So what does it look like? Well, that chaos experiment looks like this. It's a declaration of intent and what we actually expect from our system. Now, it's not a test. We're not going to check things aside from the steady state hypothesis, but we're going to massage the system and look at the system from outside and see how it responds. Basically, to help us as engineers make rational decision based on data that we collected from chaos engineering experiments. So in a Chaos Toolkit experiment, we define a steady state. It's not compulsory, but at this stage, we know what we're looking for, and we know what normal looks like to our system. So we need the front-end app to be alive, and we need to respond with 200. Now, what happens in Chaos Toolkit? It's going to run those two things, and the first time it runs that is it says if any of those two are not met, we bail. There's no point in going forward and breaking stuff because the system is already out of order. So how can you actually make sense of what you'd get from that? Then we're going to run the experiment and we're going to rerun that steady state again, but this time to tell us it's still met. That would be interesting because if it is, then either we checked for the wrong thing, or that means that what we checked was right, and luckily enough, it doesn't impact what we're interested in. It's the availability of our system. So how do we do that? Well, in the chaos experiment, we have actions that basically tell us we're going to vary something in our system. In this case, we're going to kill the database master. Kill is a bit strong word actually because we gracefully terminating the pod. So database has the time to say, well, okay, we're going to I'm terminating, so pass on the master side to the other instance so that, still someone being the master. And we got some probes so that we can create a nice report made of logs of our application, but let's not dwell on that. All right, now we have an experiment. We have declared that experiment. We're going to actually run that experiment, and we're going to use the Chaos Toolkit to do that. So here we basically run those experiments. And interestingly, we should be seeing the database going away. So that's because we're not talking the database and to the application through the ingress controller. And that database pod goes away because we're terminating that pod, right? So what we're interested in now is to see if the steady state is still met now that we killed. And it isn't. And that's a beautiful thing here, is it acted like we thought it would. Hunch was good. It broke. Let's face it, it just broke. So basically what it tells us is the before was okay, but it wasn't met afterwards. And we see that from the log of the Chaos Toolkit experiment. Now, let's go and find a response. So obviously as a developer, I might run into the code and fix the thing, but the appropriate way when you're chaos engineering something is to gather the team, and that's why Slack is so interesting here. Gather the team and discuss, okay, this is happening. How do we how do we fix that, right? How do we respond, actually, more than fix? Because fixing is not always inside the code. Here we're going to do that in the code, but purely for demo purpose. But in general, you may find that the code is the wrong place to actually respond to that, because it's too weak, or because you actually cram operational concerns into the code, and that shouldn't be the case here. Right, so what we're going to do is basically apply a little patch, because I couldn't bear typing that again, and just look how it looks, see how it looks. So what we did is that call now is surrounded in a try except clause, and what we do is, because we know the framework we're using to talk to the database promises that if one connection from the pool is off, the whole pool goes away, and it gives us a new pool to a new database if there is one, and which is exactly what we want, right? We kill only one instance, not the two of them. And that's why I'm saying the code is not necessarily the right thing, because if the two go down, maybe how do we deal with that? Maybe circuit breaker would be a nice idea, but something else. It could be operational here. So at this stage, okay, we fixed it. We're happy bunnies. It's a bug fix, let's say. So we're going to increase that. Right, at that stage, what we do is we say, okay, we're going to commit this. DB loss response, and we're going to do this. Yes, we're going to push. It's probably going to, yeah, because I changed. So let's rebase first. Yeah, happy. Let's push now. Right, at this stage we've pushed a fix, but it's not going to get released. Remember that we're using Weave to automatically deploy a new change in prod, but because it's only caring for same version, we're going to tag so that it's available to Weave. We're going to tag like this and push like this. Happy. Blah. So it's going to build. There you go. So it pushed, and now let's wait for it to tell us that it's going to release a new version in prod. So it picked up that there is a new one. So hopefully, there you go. It automated, it released, and now if we're coming back here, right, we see that one. Where did you go? There you go. That one a few seconds ago. So it's been just released. Now it's talking to, it's going to tell us, yeah, there you go. The application, the database is running. And it's running, interestingly, it's this one, it's 1. It was 0 before, because 1 has become the master when we terminated the first, the other master. That shows as well how the database, rebalanced itself. So at that stage, we're like, okay, does that work? Can we rerun that experiment again and get approval that the response was the right one? Let's try. So again, things are going to go away. Front end is gone. Front end database, I mean. Let's wait for it to come back. And that's all done by Kubernetes. Like I said, we don't have rollback, so it's done automatically for us by the system. That's why it's so useful to actually use Kubernetes in the first place. Right, it went back to 0 because that's the new master. And if we look there, we've got a message, nice message, that in that case, steady state was successfully met. So that shows us that through Chaos Toolkit, we were able to ask a question and try that question against the system. We discover weakness, we give a response. Whether or not that's a right response on the long run, we'll see. And that's why chaos engineering is an ongoing task. It's not a one-off. But we gave a response to something maybe we didn't think about while we were testing, right? So it's an interesting aspect of chaos engineering. It answers question, or it allows you to ask questions that you wouldn't necessarily think about while you're developing. And we rely on Weave and the awesome features of Weave of automatically releasing that for us into a cluster, and basically allowing for a very smooth automated flow basically.